Okay, so today we have this question from May-June 2022, Paper 2, Variant 1. 15 mark question. Okay, figure 7.1 shows a toy helicopter. It can hover and travel through the air. A student flies the toy helicopter on a journey from A to B to C to D at a constant height. Okay, the hover is at a constant height and it is traveling like this. The height is not changing. The height is fixed. The student flies a toy helicopter on journey. Okay. Figure 7.2 is a scale drawing of the path of the helicopter viewed from above. Okay. Determine the total distance traveled by the helicopter. You can see the total distance is the path followed and it is here 40 meters, then 35 meters, and then 10 meters. Okay, 10 meters, then 35 meters, then 40. So 10 plus 35 is 45, 45 plus 40 is 85. So 10 plus 35 plus 40, which will be equal to 85 meters. The toy helicopter makes the journey in 40 seconds. 40 seconds. So calculate its average speed during the journey. So average speed is total distance over total time. So the total distance is 85 and the time it took is 40 seconds. So 85 divided by 40 is 2.125. So it will be 2.1 meter per second in two significant figures. Okay, state the difference between distance and displacement. So the difference between distance and displacement is distance has no direction, but displacement has direction. So I will write displacement has direction, whereas distance does not have. Determine the scale used to construct figure 7.2 and complete the sentence. Okay, for this, uh, when this paper was there in on the exam day, it was the paper printed on some format, and when you use the scale, the marking scheme is normally according to that. So what we are going to do here is we have to put our scale on any of these distances and check what is the distance. But obviously, the size of this picture is not exactly the same as that it was printed on that paper. So what I'm going to do right now, I will check the answer from the marking scheme. What we are going to do here is basically we will measure the distance for 10 centimeter, 10 meter, that 10 meter is equals to whatever the centimeter is. Then we will divide that by 10 to get 1 meter, or we will get divide by this number to get 1 centimeter. What exactly is required here? The requirement here is the 1 centimeter. For example, if 10 meter is equals to 2.5 centimeter, then what I will do 1 is equals 1 centimeter is equals to 10 divided by 2.5 meters. Right now I'm getting 4. So it means 1 centimeter is representing 4 meter, which is not actual value. What I'm going to do here, I'm just checking it from the marking scheme. The actual answer. So according to marking scheme, what I deduce here, when you measure it by using a scale, it will come out to be 2 centimeter. So what I will observe here, that 2 centimeter is representing 10 meter here. So for 1 centimeter, 10 divided by 2 will give me 5 meter. So it means that I was not supposed to do it here. So it is basically 5 meter. So 1 centimeter on the diagram represents 5 meter on the path. Use figure 7.2. Determine the size of the displacement of point D from point A. Show your working. Okay. Displacement of point D from point A. So the displacement is the shortest distance between 2 points. From D till A, this is the shortest distance I have. What I'm going to do, I will put up my scale here and find out how much the distance is between A and D. Once I find it, then I will use my scale, that whatever the centimeter is here, I have to multiply it by 5 to get the value in meter, because they are asking the size of the displacement. And as they have mentioned here, the actual value we have already calculated, we have to give the actual answer. So by putting up a scale here, we will get 9.2 centimeter. So 9.2 centimeter. Then what I will do, I will multiply by 9.2 by 5. When I multiply 9.2 by 5, I'm getting 46. So it means 46 meter is the answer. Another way to cross check your answer is that draw a line from this point. So you know this is 10. So the remaining distance here will be 30. And this vertical distance is 35. So it's 30, 35, and you are required to find the hypotenuse. Use the Pythagoras theorem. So once you put in the calculator, 35 square plus 30 square in the root. Again, it's 46.09. So it will be 46 meter. So it is another way to cross check your answer. Determine the angle between north and the direction of the displacement of point D from point A. So from that angle between north and the direction of displacement from A. So let me clear this first. So this is north in upward direction, and from A they are asking from A the angle. So this is the angle that they are asking you to calculate. So again you have to put up the scale. This is horizontal, which is 0. So this will be something around, if this is 49, from where? From here. So 48 almost. So 90 minus 48, I will get 42 degree. So exactly I'm getting 42 degree here. So I will write 42 degree. State what is meant by velocity. Displacement covered per unit time. So this is the definition of velocity. Now, another toy helicopter flies directly from point A to point D in 40 seconds. Explain why the magnitude of velocity of this toy helicopter is smaller than the answer in part A part 2. Because in A part 2, we calculated the average speed by putting the total distance, but we know for velocity we have to put displacement which is shorter, and I have calculated here it is 46 meter. If displacement is less and the time is same, obviously displacement over time, less displacement at the same time will give me a smaller answer, because initially we did 85 over 40, but now I have to do 46 over 40. Obviously I will get the lower answer, so the velocity will be less. So why the magnitude of velocity of this toy helicopter is smaller than the in A part 2? Because displacement is the shortest distance. It's a 1 mark question, so no need for further explanation. When the toy helicopter hovers at D, its motor fails and it falls. It reaches terminal velocity as it falls. Explain in terms of forces and acceleration. What happens as the helicopter falls and reaches terminal velocity? So explain in terms of forces and acceleration. You have to mention forces and acceleration, and it is reaching terminal velocity. So this from this topic we know I'm writing here. So I will explain as well a little bit, because it's a topic which needs a lot of explanation. If you are not clear on this topic, you have to read the topic from book or anywhere from where you're studying. So as it falls, air resistance acts on it. And as the speed increases, the air resistance also increases, which in result decreases the resultant force and acceleration. When air resistance becomes equal to the weight, resultant force and acceleration becomes zero. an object reaches terminal velocity. So if you're not clear on this topic, you have to study this topic and then you will understand the answer because this is in detail. So what I can do here is simply say that when something falls, it accelerates and air resistance acts on it. As speed increases, air resistance also increases. So the resultant force decreases. When the resultant force decreases, acceleration decreases. And when a time is achieved when air resistance becomes equal to the weight, so the resultant force becomes zero and the acceleration becomes zero. An object moves with a constant velocity. Okay, next question is from 2022 October November, paper 2 variant 1. 7.1 shows a child sitting on a sledge on a snow-covered hill of constant slope. At time t is equals to 0, the child and the sledge begin to move down the hill in a straight line. When the child sees a wall ahead, he applies the brake. The child and sledge continue to travel in a straight line until they come to a stop before hitting the wall. The speed time graph of the journey is given here. The brake is applied at 26 seconds. Figure 7.2 shows how the speed of the child and sledge varies over the whole of the journey. Explain why t is equals to 0 between t is equals to 0 and t is equals to 26. The speed varies in the way shown by the graph. So between 0 and 26. So this is the whole same story that I have written in the previous question about the terminal velocity, because you can see here that it's a speed time graph and the gradient of a speed time graph gives us acceleration, and we can see that the acceleration is decreasing until the acceleration becomes zero and the speed and the object reaches a constant velocity. And when this happens, when resultant force becomes equal to zero, so again, as the speed increases, air resistance increases, and the resultant force becomes equal to zero. So here, um, okay, yeah. So now I have to explain for 3 marks. As the speed uh, increases, air resistance also increases, which decreases the resultant force and acceleration until air resistance become equal to the force driving it downward. And resultant force and acceleration become zero object reach constant speed. You can short it down. At 26 seconds, the front of the sledge is 35 meter from the wall. Because at 26 second here, the person has applied the brakes and after some time it stopped. When the person applied the brakes, it is 35 meters from the wall. So this is the wall. Let's suppose right now the person is at this point and this distance is, let's suppose, 35 meter. Okay. Determine the distance between the front of the sledge and the wall when the sledge stops. Now, when the person applies brakes, maybe at this particular point, let me change the color. Why is it lagging? So let's say at this particular point it stops. So this is the distance it covered before stopping. Let me write it D. So what they are asking, distance between the front of the sledge and the wall when the sledge stops. So this is the distance that they are asking you to calculate from the wall and the sledge. So what is required here? We need to find D. If we subtract D from 35, we will get this distance which is from the wall. For this, we know we have a speed time graph, and area of speed time graph gives us distance. After the brakes are applied, the distance D will be calculated by the area of this graph from this point. And we know, as it is mentioned, that the brakes are applied at 26, and at this particular point, it's the speed is 16 minus 12 divided by 10, it is 0.4. 1, 2, 3, 4, 5, 6, 7, 8 into 8, 3.2. So it is 15.2. So height is 15.2, base is from 26 to 28, and 1, 2, 3, 4, 5. So it will be 30. So 26 to 30 is 4. So base is 4 and height is 15.2. So area of triangle will be calculated here. Half 4 into 15.2, it will be 30.4. So for the distance which is required, 35 minus 30.4 gives me 4.6. So the distance when the sledge stopped is 4.6 meter. At 26 seconds, the child and sledge begin to decelerate. Determine the size of deceleration. Obviously, it's a straight line and the deceleration is constant. We need to find the gradient because the gradient of speed time graph gives us acceleration, and the gradient here will be negative. Negative will be deceleration here. So delta y over delta x. So for deceleration, we have here the points are 26 comma 15.2, and here the points are 30 comma 0. So 15.2 minus 0 over No, 0 minus 15.2 and 30 minus 26. So 15.2 divided by 4, I'm getting 3.8. So minus 3.8, obviously it is deceleration, so it will be negative. And the unit of deceleration is meter per second square. The mass of the child is 46 kilogram and the mass of the sledge is 9 kilogram. Calculate the resultant force. So force is equals to mass times acceleration. Mass will be 46 plus 9, 55, and acceleration is 3.8, 209. So in two significant figures, it will be 210 Newton. State the energy transfer that is taking place as the child and sledge decelerate. So brakes are applied, deceleration is there. So it has some speed and height. So it has both kinetic energy and potential energy. So initially it has from kinetic and potential energy. Two, because the brakes are applied and it is stopped by the friction. Friction causes thermal energy to dissipate and it will stop. So it will not have kinetic energy when it stops because it is not moving. So it means all this energy will be converted into thermal energy. Why kinetic energy is converting? Because initially it has speed. Why potential energy is converting? It's a gravitational potential energy. I'm mentioning it here because it has some height. Okay. At 26 seconds, when the brake is first applied, the child jerks forwards on the slope. Explain why. So because of his mass, because mass is depend inertia depends on mass basically. So inertia resists the change in state. So when the brakes are applied, is his mass will resist the change in state.